Cloud is difficult to learn. Cloud is only for techies. Cloud certifications take a long time to do. No, no, and no again. Cloud is easy to learn, and you can do some of the beginner cloud certifications in AWS, Azure, and Google Cloud in less than 2 weeks. How do I know? I'm Ranga Karnam. I'm 10x certified in AWS, Azure, and Google Cloud as well. Our courses are helping thousands of learners do their cloud certifications in AWS, Azure, and Google Cloud. In this series of videos, we'll be focusing on cloud fundamentals. Once you understand the fundamentals of cloud, you will see that learning AWS, Azure, and Google Cloud becomes really, really easy. Are you ready to make learning cloud easy? Let's get started. In this video, let's talk about regions, zones. Why do we need regions and zones? And we'll also talk about how regions and zones are implemented in AWS, Azure, and Google Cloud. We'll also look at some architectural factors like availability, durability, and things like that. Okay, are you ready to learn about regions and zones? Let's get started. Before we talk about regions and zones, let's start with a very, very simple use case where we would need regions and zones. Let's talk about a simple application, right? Where do we apply, where we deploy applications when it comes to your enterprises? You deploy them in data centers. So you deploy your application on a server inside a data center. Let's say this is in a location, London. So in London location, in a specific data center, you're deploying your application on a specific server. Now let's look at it from a few factors perspective, right? So let's look at latency and let's look at availability. Now the first thing is, what is latency? Now this application is deployed in London. So if somebody is accessing this application from London or somewhere inside United Kingdom itself, then they would be able to access that application in a fast way. That is what is called low latency. Whenever you build an application, you would want your users to be able to access it very, very fast. Today's users don't have any patience at all. They would want quick responses, maybe millisecond responses if it's possible. If you take more than a second to respond, most of the visitors would leave the website and go away. So low latency is very, very important. And your application will provide low latency for users in UK. So inside UK, you'd be providing low latency. But if somebody is accessing your application from some other country, right? Let's say from United States or from Australia or from India, your application is deployed in London and therefore they will have high latency. So these application users from other countries will get high latency. The other important factor to consider is availability. What if this application in this data center goes down? You just have one instance of this application. If that specific application goes down, or if this entire data center crashes, what would happen? Your application is no longer available. Therefore, your application users will not be able to access your application as well. And that means your availability is low. Whenever your application goes down or your data center goes down, your application users cannot access the application, and therefore your availability also is low. Now, think about this. How would you improve this scenario? Let's draw a new architecture. I will call this 2, and let's draw a small picture for it, right? So instead of having just one instance of the application, what I would do is actually I'll have one instance of application in one data center. So this is the same as earlier. So in a data center in London, I would have one instance of this application. However, I will add another instance of the application as well. So I'll call this app again, and this will be in a different data center 2. And let's say for a start, this is still in London, right? So what we are doing in here is we are creating a second instance of the application in a different data center in the same region, which is London, right? So let's now look at the different factors with this in mind. What happens to your latency? There is no change in latency because UK users will still have low latency and US users would have high latency because still we have only deployed our application in London. Same is the case for Australia as well. However, if you look at availability, right, if this data center goes down, what would happen? You can serve the application from this data center. If this app goes down, we can actually serve the users from this specific application. Therefore, the availability, I would say, is okay. Now, you might be asking, Ranga, why okay and not high? Because if this goes down, if the entire region of London goes down, imagine what would happen. Both the instances would be down because these data centers are still in London only. Therefore, this application would go down. Let's improve this further, right? So let's go ahead and make this little bit better. So what I'll do to make it better is, let's say I'll call this 3, and let's draw a simple architecture, right? So you have your app, you have the app in a data center, and you have the app in another data center in a specific region. And this is London setup. In London, in 2 different data centers, you have the application deployed, and you are replicating the same setup, let's say in Sydney or Mumbai or New York, wherever you'd want to, right? So you replicate the same thing out in here. Now, what would happen? Let's look at the factors now. What do you think will happen for the different factors that we were talking about until now? This is the 3. So this is like multiple regions, and in each region there are multiple data centers. Latency for UK would be low, right? So low for UK. And right now I have the application deployed in Sydney, right? It's here. So Australian users would also get low latency. Sydney is in Australia. US users, if I want them to get low latency, I can create another region in US, maybe in New York, or maybe I can have multiple regions in US as well. So I'll put a star against this. If I do more regions, then I would get low latency for users in US as well. As far as the availability is concerned, is there any improvement? Let's look at it. If this data center goes down, I can serve the application from here. If this entire thing goes down, then I can serve my application from Sydney. Therefore, the availability of this application, I can say, is high. I mean, all these are relative terms. I can even get better availability by deploying it to more regions, but it's pretty good. So I'll call this high. So what we are doing right now is the fact that by deploying the application in multiple data centers and multiple regions, we saw that we can improve our latency. We can provide low latency for our users, and we can provide high availability for our users. Whenever I'm building an application, low latency and high availability are very, very important. And therefore, all enterprises, startups, enterprises, all of them would want to provide this to their users. Now, let's take the startup scenario, right? So will a startup be able to set up infrastructure like this? Will they be able to set up a region in London, have 2 data centers there, set up something in Sydney, have 2 data centers there? Nope. It's very, very difficult for them to do that, right? So it needs, number one, a lot of money, right? So you need a lot of dollars to be able to set up infrastructure like this. And you need to build a team as well. You need to build an infrastructure team to take care of all these things. And it's not easy to do all that stuff. And imagine setting up regions all around the world, right? That's almost impossible for a startup. It's difficult even for large enterprises to be able to do that. And that's where cloud comes into picture. If you look at all the cloud platforms, they provide regions all around the world. What we are looking at is a picture from AWS, right? This is the infrastructure which is provided by AWS. All the blue ones are the regions where regions are already available. So actually, I should reword it. All the blue ones are the places where there are already pre-existing regions. And the orange dots in here are coming soon regions. There will be regions coming soon in these regions very, very soon. So if you go over and hover over one of the blue ones, I'm hovering over Mumbai, you can see that this was launched in 2016, and there are 3 availability zones in there. Let's go and look at maybe something here. Canada Central, this has 3 availability zones as well. North Virginia, this has 6 availability zones. You can see that there is a government cloud. US East Government Cloud, 3 availability zones, and Ohio has 3 availability zones as well. So what we are talking about is the fact that each of the cloud providers provide regions and zones. So let's look at AWS. In AWS, this is called regions and availability zones. The terminology is a little different in Azure and GCP. In Azure and GCP, a region is still called a region, so it's the same, it's region. However, AZs are called zones, right? So in AWS Azure, the terminology is regions and zones, and in Azure and GCP, it's called, okay, in AWS, it's regions and AZs, availability zones, and in Azure and GCP, it's regions and zones. The concept is again the same, right? The concept is basically a region is a physical geographic location somewhere in some country in the world, and inside each of the regions you would have multiple availability zones. Regions provide geographic distribution for your application, whereas availability zones provide you with high availability even within a single region. Sometimes you might want to deploy your application only in a single region. For example, in India, let's say Mumbai is the only region which is available. In that kind of scenario, even within Mumbai, you want to deploy your application to multiple availability zones, so that even if one data center or one availability zone fails, you'll be able to actually deploy, or you can actually serve your users from the other availability zones. When you look at AWS, it provides almost 30 regions. I think the accurate number right now would be 26, and I would say it would increase. Actually, with respect to all the cloud providers, the number of regions will increase. GCP, I think, is 29 right now, and Azure is somewhere at 60. So Azure is the one which provides the most amount of regions around the world today. However, I would say AWS and GCP are catching up pretty soon there as well. So regions and zones are definitely something which anybody who's going to cloud should understand. By deploying your applications, databases to multiple regions, multiple zones, you would get high availability. You will not lose data. You can ensure that your users get low latency. Now, when it comes to regions and zones, there are few terminology that are typically used, which are confusing for somebody who's starting off with the cloud. Let's quickly look at those terminology, and also we'll look at how that terminology is related to regions and zones. Let's start with a terminology which is very frequently used, which is global footprint. A lot of people say cloud enables global footprint. This is very, very simple thing actually. It just means that you can deploy applications to multiple regions around the world. A startup, for example, in India can deploy their applications to a region in US, in Australia, in Europe, and all other continents around the world. And that's what is called global footprint. A simple startup which does not have a lot of infrastructure for itself, now with the emergence of cloud and with the emergence of regions and zones that are provided by these cloud providers, can deploy applications to different regions around the world. And that is what is called global footprint. We already talked about a couple of other terms very, very deeply. We talked about low latency and we talked about high availability, right? Low latency is to ensure that your users have low latency access, fast access to your applications. And high availability is to ensure that your application is always available to your users. You get high availability by deploying your applications to multiple regions and multiple zones. The other important factor that is very, very important when it comes to the cloud is scalability. What is scalability? There are a lot of factors that can change with respect to your applications. Users might increase. The amount of data that might be present in your application might increase. So a lot of things vary with time. Maybe sometime your user base is increasing, and some periods the load on your servers is very, very high. Let's say to meet this load, you need 10 servers. And to meet this, you might need just 2 servers. So based on the load, you would want to increase the number of servers to 10. And once the load goes down, you'd want to decrease it down back maybe to 3 or 2. So this going up and going down is called scaling up and scaling down. And your application should be scalable in the sense that you should be able to increase the amount of infrastructure which is available for your application and decrease it as per the need. And to implement scalability for your application, there are two popular approaches. One is vertical scaling, the other one is horizontal scaling. Let's say I have one VM and let's say it has 2 gigs of memory right now. And let's say it's supporting 10 users. Let's say if I increase it to 4 GB, it can support up to 20 users. This is called vertical scaling. From a small instance, we are going into a big instance. We are increasing the hardware which is associated with a specific thing, right? If it's a VM, we are increasing the memory or the CPU or the hard disk which is attached with it. So this is what is called vertical scaling. Vertical scaling is increasing the hardware which is associated with a specific virtual machine. The alternative is horizontal scaling. In horizontal scaling, instead of having one instance, you would have multiple instances. So you would have multiple instances like this, right? Let's say to support 5 users, you would need one instance. To support 30 users, you might have 6 instances. Let's quickly look at one disadvantage of vertical and horizontal scaling. What is the disadvantage of vertical scaling? Vertical scaling, the disadvantage is it's expensive and there is a limit to it, right? So if I would want the most powerful laptop or most powerful computer in the world, it would be very, very expensive, right? So as you increase the size of your VM, the expense grows a lot of times exponentially. And also there are limits, right? There is a maximum amount of CPU that you can have. There's a maximum amount of memory that you can have on a specific virtual machine. So beyond that limit, you cannot scale up. So vertical scaling has its own limits. Now, what is the disadvantage of horizontal scaling? The disadvantage of horizontal scaling is when I'm increasing the number of instances to 6, I would need to have something like a load balancer to distribute the load between these. I would want to be able to have some kind of infrastructure to be able to identify the load on the application and increase the number of instances and decrease the number of instances. So it needs additional infrastructure. So you need a lot of additional infrastructure in place to support horizontal scaling. Until now, we have been talking about regions and zones. When we talk about regions and zones, which one are we talking about? Vertical scaling or horizontal scaling? What we are talking about in here is horizontal scaling. What you can do is you can have 2 instances in one region, these 2 instances in another region, and these 2 instances in another region. Thereby, you are getting scalability. So you are able to scale your application up, and you also get high availability. Even if this region goes down, you can serve the users from the other regions. So these are some of the terminology which are typically used when it comes to regions: global footprint, low latency, high availability, and scalability. What we are doing is, in the case of horizontal scaling, we are adding redundancy, right? So instead of having one instance, we are having multiple instances. And if I would want safety, if I want high availability, what I can do is, if I want 6 instances, I can have 8 instances running. Instead of having 6, I can have 2 extra instances running, let's say in another region, right? So this can be an additional region where I would have additional instances that are running just for the sake of safety. Even if this entire region goes down, my users can be served just from these 3 regions. And this is what is called redundancy. Basically, instead of just having the infrastructure to support the expected load, you will have a little bit of extra infrastructure in place just in case some failure happens. You would be able to adapt to it, right? So whatever we are doing in this specific step is discuss about regions and zones and look at some of the important terminology which is related to regions and zones. Basically, what we have been talking about is the fact that startups and enterprises need to be able to geographically distribute their applications, deploy their applications to multiple regions around the world, because they need high availability and they would need low latency. And we saw that the cloud providers provide this concept called regions and zones or availability zones to help you distribute your applications to wide geographies around the world. AWS calls them regions and availability zones. Azure and GCP call them regions and zones. We saw that AWS and GCP have almost 30 regions, and Azure has about 60 regions. Most of these regions have multiple availability zones. And we saw that regions enable you to have global footprint. They enable your applications to provide low latency to your users. They enable you to get high availability for your application, and you will be able to horizontally scale your application to multiple users around the world, to users from different geographic locations around the world. So that's about zones and regions. There are a lot more things that we would want to talk about regarding cloud, regarding compute, databases, networking, and a lot of other things. I will see you again in the next video. I'm sure you had a great time watching this video. Do not keep it to yourself. Tell your friends and tell YouTube as well. How do you do that? Like, share, and subscribe. If you're looking to get cloud certified, check out our cloud certification courses in AWS, Azure, and Google Cloud. And do not forget to check out the other videos in this series of videos on cloud fundamentals. If there is a cloud topic that you're feeling it's very, very difficult to understand, do post it in the comments and we will make it simple for you. I'm sure you had a great time watching this video, and I'll see you again very, very soon. Until then, here's bye from Ranga at In 28 Minutes. See you soon.